Today we'll start the lessons which are related to the introduction to computer system. Under this, we will discuss about introduction part to the computer. Initially, we start on the generations. Now, computer generations are divided based on the technologies that they had used. Now, in first generation, main technology that we had used a vacuum tubes. So because of that, in first generation computers are very slow and unreliable, the first generation computers, and very big or very large in size, and lot of power was consumed. But when it's come to the second generation, the technology was changed to transistors. So because of that, computer speed was increased and reliability was increased, size was reduced. Uh, when it comes to third generation, they have developed integrated circuits where there are thousands of transistors. Then the computer size was further reduced, speed is further increased. And then when it comes to fourth generation, so they have developed the microprocessor, which has inside several ICs together. So then the computer size is further reduced and computer speed is further increased and reliability was increased. Currently, we are in the fifth generation. Their main motivation is artificial intelligence, that is developing a computer where it can think similar to the human. But it is not easy task. There are a lot of universities in the world doing a lot of research works to add the intelligence to the human. So in that case, a lot of people are doing the research in developing this AI, because currently computer doesn't have the intelligence. Some parts are automated, but some parts are not yet automated because of several reasons. Therefore, here a lot of researchers in the world doing a lot of research works in a lot of universities to develop this AI part. Uh, because of some of the current computer, as you know, everything is represented by binary 1 0. So in computer, everything expect by 1 0. But the problem is we cannot represent everything by numbers, because in computer, all the data that you're going to store, like when you take the document, images, audio, video, animations, everything representing as a numbers, 1 0 patterns. But there are some aspects or some qualitative data which cannot be represented by numbers. That is the main issue they are currently identifying in implementation of the AI. Now, as an example, some emotions cannot be represented by numbers. So that is a one problem where they find to implement this AI in the computer. Because now we can say someone is happy or sad or angry. So those things actually we cannot measure by numbers. We can't represent by numbers. But computer wants everything by numbers. So those are some issues actually. Now then the when you take some understanding in intelligent way, those are necessary. If there's a robot, uh, the robots will work our instructions clearly if you can give as a numbers. If you just say to the robot, okay, go 1 meter, he exactly goes to 1 meter distance to the whatever given location. But if there's a robot, if you just say come closer to the table, or you can say you need to go to closer to the table, then he doesn't know how much closer. What do you mean by the closer? When you say near, if there's a robot, if you just say go near to the let's say wall, then he doesn't know what you mean by the near. But if it is a human that knows when you say something near, closer, he can get the understanding. But we cannot implement something like common sense are difficult to implement in the robots. So that's why people are doing a lot of research works at contributing to develop the intelligence system, because it is not easy task developing the intelligence. So that's very simple background details about the generations. But you can get further detail if you just search the internet. You can see a lot of information are there. If you want, you can just read. But here I'm just giving some brief introduction to that. And again, just come to the computers. Mainly there are two types of computers, portable and non-portable. So portable means a computer where you can move, which is very small in size and lightweight. Non-portable means very large computers, relatively heavy. It is difficult to move here and there. So as an example, non-portable computers will be the server computer, workstation computer, desktop computer, all-in-one computer. But portable computers which you can move here and there, laptop computers, notebooks, tablets, and smartphones. These are the other portable computers which you can move here and there. We call them as a portable computers. So these are some of the computers that you have. Now this all-in-one computer means basically all the parts are together without having the system unit like this. All are together in a this display panel. So that is we call as a all-in-one computer. Uh, can you hear me? I think it's raining here.
Yes, sir.
Okay. So if you have any questions, you can just ask at any time, interrupt me and ask the questions. And again, the chat box is there where you can try it if you have any questions. It doesn't matter, even I'm teaching, you can ask any questions. So when you take the computer system, these are the main components. We have some input devices, output devices, storage devices, and the CPU, or what we call the processor, and the communication devices. So these are the main parts of the computer system. Now you need to have some understanding about this block diagram. The block diagram means we are representing all the parts in the computer as blocks. So therefore we call as a block diagram. So with this, you can get some understanding about what are the components in the computer and how are they connected with each other. What is the purpose of each component? Like you must have some understanding about each. Now as given here, through the input devices, you can input the data. Then that goes to a kind of memory, what we call the RAM, or we call as a main memory, or sometimes we call as a primary memory. So it's a kind of volatile memory. Volatile means when you switch off, content will be erased. That is called the volatile memory. So through that, you can send to the data to output devices. Now, since this one is volatile memory, once you switch off, content will be erased. We need to have a kind of secondary memory where you can store the data permanently. Even you switch off, content will not be erased. That is equal as secondary storage, basically the hard disk. In the hard disk, it is very slow, but you can store the data permanently. That is, when you switch off, data will not be erased. So the main secondary storage is a hard disk. But as a secondary storage, you can use a CD, DVD, pen drive. Those can be used as a secondary storage where data can be stored permanently. Even any power goes, doesn't matter, data will be there without any issues. Then in computer, the most important part is this one. That is what we call the CPU, Central Processing Unit, or what we call the processor in short. So that is the most important part. It is just like a brain of a human, we call as CPU. So he is the one who does all the controlling and execution, everything's done by the CPU. So inside the CPU, mainly we have these components. That is, you have the ALU, arithmetic and logic unit, CU, control unit, level 1 cache, registers. Then what are these components? So ALU is the one who does all the arithmetic and logical operations. So arithmetics means addition, subtraction, multiplication, divisions, like those operations. Logical means we discuss the logical operators later, like and or, not, exclusive or, like those operations are done by the ALU. And what is a CU? CU is a control unit. This control unit is the one who can control. That is why this control signal, these arrows are control signals. So he can control the input device, he can control the storage device, he can control the memory, he can control the output device, he can control the registers. Like the control unit is the one which will control and coordinates the entire operations of the computer. And again, control units later will discuss is the one who decode the instructions also done by the control unit. So in addition to that, we have a kind of memory in computer, registers. Remember, registers are the fastest memory in computer as well as smallest memory. So registers are very fast but very small because it is very expensive, because of which is very fast. And what happened, since these registers are very small, after some time period, these registers will be full. Register will be full. Why? It is very small. It's very small. So therefore, so what we need to have some other storage where some data must be stored. If this data access again and again, if they are not accessed, you can send back to the main memory and the hard disk. But if you need some data which are needed for the CPU again and again, those data will go to the memory called as a cache, level 1 cache. We call that as a level 1 cache, or we call as a primary cache. So now for this level 1 cache or primary cache, remember we are not storing all the data. We have some cache management algorithm which determine what data should go to the level 1 cache. So whatever the data which are possible, which are very having possibility to use again and again, so that data will go to the level 1 cache. Because if your data is in the level 1 cache, now if the data is in the register, CPU can get it very faster and process it. But if the data is not in the registers, normally you have to go to the main memory to get the data, or sometimes you have to go to the hard disk to get the data. But remember, this main memory and the hard disk is very slow with compared to the registers. Therefore, if the CPU is going to the main memory or hard disk again and again, your program execution will be very slow. If you can keep all the data in the registers, then you can complete the execution very faster, very quickly. But the problem is you can't keep all the data in the registers because that is too small. So therefore, whatever the data which is used by the CPU again and again, or the data which is used most frequently, will go to the level 1 cache. It goes to level 1 cache. And from there, CPU can get the data for the processing. So this level 1 cache, remember, it is larger than the registers. So level 1 cache, this is I have just given the increase in order. Level 1 cache is normally larger than the registers, but level 1 cache is slower than the registers because registers are the fastest memory. So the next fastest is level 1, next fastest is level 2, and next one is level 3. Then the RAM and then the hard disk, that is the speed decrease in order, but the size is increasing. So when you go from here to there, speed is decreasing, but the size is increasing. Size is increasing. So that is the way it works. Now we put the data to the level 1 cache. But what happened after some time, level 1 cache also can be full. In that case, we have two more cache memories outside the CPU, level 2 cache and level 3 cache. So level 2 cache we call as a secondary cache, level 3 cache we call as a tertiary cache. So when this one is full, what happened? We put the data to level 2 cache. If the level 2 cache is full, we put the data to level 3 cache. So that is how it works. First we fill the level 1 cache. After that, if it is full, we go to the level 2 cache. After that, we'll go to the level 3 cache. That's the order the data is inserted to the cache memory if it is full. So that is the very basic introduction to the CPU or computer system block diagram. Now this is same explanation. In the CPU, we have these component registers, ALU, control unit, and primary cache. Now registers are the fastest and the smallest memory. ALU do all the mathematical operations. Control unit is the one who control and coordinates everything and decode the instructions. Primary cache is used to store the more frequently. Then when you take these CPU manufacturers, mainly we have the Intel, AMD, and Apple are the largest manufacturers for the CPU. And when you take these computers, currently we have more than one CPU actually. Initially, computer has only one CPU, like Pentium 1, 2, 3, 4 computers. They had only one CPU, but currently we have more than one CPU. Now, dual core, or what we call this double core, which has two CPUs in full. Quad core means there are four CPUs. When you take i3, i5, i7, i9 like computers, which has more than two CPUs inside. So I'll send these slides for you to study later. You can read them later. And again, CPU speed. Remember, CPU speed is measured by unit called as a hertz. Hertz. So in that case, 1 kilohertz means 1000 hertz. 1 megahertz means 1000 kilohertz. 1 gigahertz means 1000 megahertz. Now, what is the meaning of this hertz unit? Remember, meaning is now CPU speed is measured based on how many instructions executed per second. That is, when you take 1 second, how many instructions can be executed, which is we called as the measure the speed of the CPU. Now, as an example, just a simple example, if the computer speed is 10 hertz, as an example, the CPU speed is 10 hertz. What is the meaning? The meaning is it can execute 10 instructions. It can execute 10 instructions per second. That is the meaning. So remember, CPU speed is measured by 10 hertz, the hertz. It is, if you take the example as a 10 hertz, what's the meaning of the 10 hertz? Within 1 second, how many instructions can be completed, executed? 10 instructions can be completed. That is the meaning. Then you can see current computers are gigahertz. Gigahertz. So then if the computer speed is 2 gigahertz, the real meaning is 2 gigahertz means current computers can execute close to 2 billion instructions. 2 billion instructions per second in general. So you can imagine the speed. The CPU can execute 2 billion instructions per second if it is 2 gigahertz. So therefore it is very fast. And in your computer, if you go to the task manager, you can get these details. What is the speed of the machine and how many cores are there? What are the level 1, level 2, level 3 cache memories? Like these informations you can get from your computer by running this task manager. And memory, as I told you, memory, we have the volatile memory and non-volatile memory. So volatile means when you switch off, content will be erased. Now, when you take the memory registers, level 1, level 2, level 3 cache, RAM, like those memories are volatile. That is, when you switch off, it will be erased. But non-volatile means hard disk, ROM, CD, DVD, VCD, like non-volatile. That means if you switch off, content will not be erased. And again, memory speed. Remember, the memory speed is measured by the unit megahertz. Megahertz is a unit which is used to measure the speed of the memory. In addition to that, you need to have this knowledge also. When you take 1024 bytes, because computers are mainly in binary format, so therefore, if it is 1024 bytes, which is equal to the power 10 bytes, to the power 10 bytes, which is equal to what we call 1 kilobyte. And 1024 kilobyte is equal to the power 10 to the power 10 kilobyte, which is equal to 1 MB. And 1024 MB equal to the power 10 MB, which is equal to 1 GB. And 1024 GB or to the power 10 GB is 1 terabyte. And 1024 terabyte or to the power 10 TB is 1 petabyte. Like, you must have some idea about these units. So every time it is multiplied by 1024, not 1000, because computers are binary system, which is working with 2 to the power. 2 to the power 10 is equal to 1024. So just remember that information. Is it clear? Any questions? Any questions you have? Any question? Okay, now then remember this memory, we have the primary and the secondary. So primary memory is the normally main memory. Secondary means mainly the hard disk, CD, DVD. Now secondary storages are developed with three technologies. Initially, secondary storages were developed by magnetic media. That means to store the data, magnetization was used, like hard disk, magnetic tapes, floppy disk. Floppy disk nowadays we are not using because it is small. So they are using the magnetization. So we call them as a magnetic media. Then we have another category, optical media. Optical media means they are working with the laser beams to store the data. Especially CD, DVD, and Blu-ray are working with the optical storage, where it is working with the laser beams. Third one is solid state. Now, when you take the previous storages like hard disk, CD, DVD, floppy disk, like everything, they are rotational devices. They have something rotating. But when you take the solid state means they are not rotating. They are not rotating. So that is what we call like pen drive, memory cards. They don't have anything rotating inside. So those are we call as solid state devices. So that way you can categorize secondary storages. Then when you take this input, output, and storage device all together we call as a peripheral devices. So then peripheral devices means all input, output, and storage devices together. So you may be familiar with this. What are the input devices? Keyboard, mouse, microphones are kind of input devices. Monitor, printer, speaker are kind of output devices. But touch screen work as a both input and output, because in the touch screen you can input something by touching. And again, for the touch screen, you can view something. Therefore, it works as a both input and output devices. The storage devices are hard disk or disk, optical disk, flash drive, tapes, like those are hard, storage devices. So I assume you are familiar with these devices actually. So when you take the input devices, mainly the keyboard is input device and microphone is input device. And all scanners are input device. Now, when you take this scanner, flatbed scanner means the scanner which can scan your document, images, and everything can be converted into soft copy and stored in your computer. And OMR is the optical mark reader, which is used for the MCQ marking systems. As you know, when these online exams are conducted, when the exams are conducted, where answers can be marked in the MCQ paper. So in that case, cross sign or circle must be identified. So those are identified by the OMR, optical mark reader. ATM also kind of input device where you can input your cards and everything, you can get the cash. OCR, optical character reader, is also kind of inputs that is used in the scanner. Because in the scanner, once we scan a Word document, we want to convert that into the text. So there you have to identify the characters. Optical character scan is the one which will identify the characters. Barcode reader also input device. You can see the supermarket, their items details are collected from the barcodes. That is also input device. MICR, magnetic ink character reader, is used in basically banks to validate the checks. That is also input device. Then you have the pointing input device like mouse, light pen, touch screen, joysticks, like those are pointing devices. Then imaging and video input devices like webcam, digital camera, CCTV, all these are again working as a kind of input device where you can get some inputs and store in the computer storage. Those are the input devices. And the output devices basically produce the hard copy, soft copy, and the sound. Now, hard copy means basically printouts. So, hard copy is produced by the printers. Soft copies are produced by the monitors and the projectors. And sound is produced by the speakers. The printers, mainly there are two types of printers, impact printers and the non-impact printers. The impact printers are the one which is used very early actually. The impact printer means it has a hammer-like tool which will impact on the paper to print the characters. When you take the dot matrix printer, line printer, decibel printer, like those are mainly based on the what we call impact, which is very slow and very noisy, low quality one. But currently we are using the non-impact printers where there is no hammer-like tools, but they are using different kind of spray mechanism to produce the outputs on the paper, like laser printer, bubble jet printer, inkjet printer, thermal printer, plotter, like they are using the non-impact technology. Monitors, earlier we have used the CRT, cathode ray tubes, like very large monitor. But currently we are using the LCD, liquid crystal display, and LED. So those are some of the basic introduction to some output devices. So I assume you are familiar with these things previously. So this is the same thing, monitors. We had the CRT, LCD, and LED. Currently we are using the LCD because which is less electricity and less space with compared to the cathode ray tube, which is very old monitor. And to connect the other external devices to the computer, we have the different ports. In computer backsides, you can see there are different ports where you can connect the different other external devices. Now to connect your monitor, we have the VGA port. So some of them are on board, some of them are separate VGA port card is there. So when you have the separate VGA card, you can have separate memory and the separate processor where you can connect the VGA cable to this VGA port. That is basically to connect your computer and the monitor. In addition to that, we have to connect the other devices. In addition to the VGA port, we have the HDMI port. That is called as a high definition multimedia interface. Normally, that is used to connect your computer and the televisions, or your computer and the projector can be connected with that device easily, or DVI, digital visual interface, that also can be used to connect the TV and again the projector. So those kind of ports are available in your computer to connect the different external devices. And we have the sound port where you can connect the other sound devices which has different colors. If it is a light green, that indicates for speaker or headphone. If it is a light pink, that is to connect the microphone. If it is a light blue, we can use any other input devices where you can send the sounds to the computer. So those are some of the very basic terms in the computer system. And again, you have the USB port. Currently, most of the devices are connected by the USB port or Universal Serial Bus port. Earlier, to connect the keyboard, mouse, printer, scanner, they have a separate port actually. But nowadays, all the keyboard, mouse, scanner, barcode readers, everything, printers can be connected through this USB port. That is very advantageous because then easily you can connect all the other external devices using this USB port. But early days we had separate port for each one. But nowadays everything can be connected. Most of the parts can be connected to your computer through the USB port. Now, so to connect the network cable, we have this RJ45 connector. Through that, you can connect the network cable to your computer. Then the other most important thing in the computer is the software. So the main software you need in your computer is operating systems. So without having the operating system, you can't do anything. So in your computer, mainly you need to have the operating system installed to run your applications. Like you need to have the Windows, Linux, or Ubuntu like operating system must be installed in your computer to work with your computer. Otherwise, you may not be able to run any of the applications because this operating system you can see here, this operating system is working as another layer for all the applications because this operating system hide all the complex part of the hardware. That is why in our computer, as you know, we have the CPU, RAM, hard disk, IO devices, like a lot of devices are there. But as a user, when you are going to work with the computer, we don't see any of them. We don't see the CPU, we don't see the RAM, we don't see the hard disk, we don't see the IO devices. How are they working? What kind of scheduling is done? Like we don't know. Why is that? Managing the CPU, managing the memory, managing the hard disk, managing the input output devices, all things are done by the operating systems. So operating system has very good sophisticated complex algorithms to manage all of these resources. Therefore, as a user, we really don't know how these hardware is working. All the hardware details are hidden by the operating system by providing very user-friendly environment. So therefore, without having the OS, you may not be able to do any tasks in your computer. So this operating system, mainly there are two types, open source and closed source. Closed source we call as a proprietary OS. What do you mean by the open source? Remember in computing, what do you mean by the source in software engineering? Or source means the program code. Now you can use some program languages like C, C++, Java, Pascal, Python, C Sharp. Like there are a lot of program languages. By using these program languages, what you can do is you can write a program. So basically program means set of instructions. Then computer follows that instruction and produce the outputs. So when you write a program in C or Java or whatever the language, once you write a program, that program code we call as a source code. Source code. Basically source means program code. Then what do you mean by the open source? The open source means that program code can be open and see what are the data structures and algorithms inside the code. So then open source operating systems are always you can download from the internet freely and you can open the code and see what are the data structures and algorithms available. So that is what we call open source. Closed source means they are not available in internet freely download. You can't download from the internet freely. That is you have to buy. Still the code is locked. You can't open and see the data structures and algorithms. When you take the Linux, Unix, Ubuntu, Fedora, Android, like those operating systems, remember, they are mainly what we call open source. You can just download from the internet and install in your machine. And again, you can modify the code. But Windows, Macintosh, those like operating systems you have to buy. Still, it is locked. You can't open and see the content. So that is some introduction to this what we call operating systems. So that is kind of very basic introduction part to the computer system.